everyone, this is Dr. B. Maithili from the Department of Biotechnology. I am here to present my topic on process design and control of fermenters. So bioreactor is one instrumentation that requires a controlled environment for microorganisms to grow. So while designing this bioreactor, we need to consider some of the essential factors before designing, which includes aseptic environment is the first main thing that needs to be considered while preparing this particular bioreactor, and it should provide adequate aeration and agitation for the microorganisms to grow. Followed by, it should also give us less power consumption, and it should have a facilitated temperature control and pH control along with sampling facilities. Followed by, it should also have evaporational loss which is minimized in a way such that it should also have a minimal labor use, followed by and wide range of processes should be supported by the fermentation process by the bioreactor, and it should also be made by a cheapest material that should serve for a long period of time. And it should also have an adequate service provisions for individual biofermenters, and this is some of the designs that I would like to project for the bioreactor design, and this is one simple design, and followed by we have multiple designs which is with additional ports are available in a bioreactor, facilitating various applications like temperature control and pH control. And this is one complicated reactor which is designed with number of water cooling systems and a pH control system, acid port, sampling port, everything is there in this particular specified equipped bioreactor. And next is a simple reactor design which we can use for examination purposes for drying things. And here is the live model of how the reactor will look exactly. And this is the baby fermenter which has the capacity to ferment a liquid of about 2.5 liters, and it is normally made of glass, and it has a specific lid which is made up of stainless steel, and this steel will have a provisions to add all your nutrients as well as have your sensors inserted, and our aeration provider will be there, and if we need to sample something from the particular fermenting liquid, then we can also access through these ports available in the lid of the particular fermenter. And this is how the fermenter will be there in the industrial setup. It will be specified, placed in a particular area, not in a fixed mode. It will be enabled for transporting from one place to another place. Now let's see some of the design parameters that needs to be taken while designing a biofermenter, which includes body construction, temperature control, aeration and agitation, and maintenance of aseptic conditions followed by control system. And first let's see about the body of construction. This body of the biofermenter is normally made up of two elements, mainly glass and stainless steel. So first let's see the glass application. So normally the glass, when it's used, it is a simple thing that prevents corrosion. Whereas if you go for any other materials for the construction of bioreactor, it takes the advantages of using other metals, but the life will be there, but there will be corrosion will be there. So it should not facilitate corrosion, as it may also aid for the contamination. So here when we consider constructing of a fermenter in a laboratory scale or the industrial scale, first if your application is to be more aseptic condition, then we need to choose glass as the primary for mode of material for construction of your bioreactor. Next, when you see the stainless steel, it should be facilitated normally with the 10 to 15% of stainless steel with the chromium and nickel should be there, which will be acting as an anti-corrosive agent for the stainless steel material. Normally a stainless steel material based biofermenter can withstand up to 25 years based on the product which we produce. For example, for the production of acetone butanol, it takes about a life of about 25 years, whereas for penicillin production it takes about a life of about 12 years, and for streptomycin it is about 7 years. So it varies based on that. Next is the important parameter is temperature control. So temperature control is essential as heat is generated during the fermentation process, mainly because of two things. One is agitation and another one is microbial growth. Let's see how to work on this particular heat reduction system. Here we require a specific system called cooling systems, which we need to calculate certain things. That is, the heat need to be exchanged for the particular reduction of heat, which is called as Q exchange, which is calculated by the Q met, that is the metabolism of the microorganisms, and the heat generated due to agitation and the heat generated due to the gas, and which should be reduced from the Q accelerated accumulation of the heat and then followed by reduction in the sensible enthalpy and then followed by reduction in the heat rate of evaporation. This heat exchange, Q exchange, is essential for to construct a cooling system that will help you to estimate the heat that needs to be reduced. Next is the aeration and agitation. So here when you consider aeration is specifically required an oxygen supply for your microorganisms to grow, whereas agitation, it's like proper uniform mixing, it's enabled because of the agitator, and this is essential because it's a part of a microbial growth where a fermenter is required both oxygen and the proper uniform mixing. If this is not properly done, your product is not going to be formed at the essential time. So in considering all this, we need to equip the particular biofermenter based on the fermentation liquid thickness, which is viscous or low viscous or medium viscous or high viscous. We need to go for selecting our agitator or aeration tools. So while constructing this particular elements, we need to take care of three constructional elements. One is agitator, which is also called as impeller, and next one is baffle, and next one is aeration system. So first let's see about agitator. So agitator, it has a specific purpose to achieve the number of mixing elements. One is the bulk fluid and gas phase mixing, another one is air dispersion, and next one is oxygen transfer, and then the heat transfer, and then the maintaining of uniform environment, as I said earlier, throughout the vessel it should be accomplished. So for all this purpose, we need an agitator to be designed for a bioreactor which we use. Normally it depends on the product which we are going to produce. So here are some of the types of agitator which is available. So first is the turbine agitator, and then band disc, and followed by propellers, paddle, and then anchor type, helical, screw type agitators are available. Let's see how it looks like. So this is the orientation of different types of impeller designs that is available, as we said earlier. So normally this is the type of blades, arrangement of blades it's like. So in the next slide we have the arrangement in the 2D as well as in the 3D form. So where the first one is the two-dimensional view, and last one is the three-dimensional view of each and every van disc, not only van disc, other agitators also. First one is the van disc turbine, and then second one is the van disc, and then third one is the open turbine, and the last one is the marine propeller. Next we have agitator which should be chosen based on the viscous of the fluid. So if it's low viscous, then normally flat blades are used, and if it is high viscous or normally for industrial, it is normally used as 6-blade flat blade disc turbine is normally used. It is also called as Rushton turbine. Next, let's see about the baffles. So baffle is the metal strip that is placed on the sides of the fermenter. So normally it's about 1/10 or 1/12 of the vessel. So it's like normally it is attached to the vessel's walls of the particular baffles. So here if you see, first one is facilitating a low viscous fluid biofermenter, and last one is facilitating more agitation, so which will help for more mixing of the particular fermenter fluid is accomplished because of the last type. The flow rate will be uniform and it will be mixed, and it will help not to adhere to the walls of the fermenter. So the microbes will not adhere to the fermenters. And here is the application of the baffles which is mentioned. So it prevents the scouring action, and it also helps to prevent the stagnant zones while fermentation is taking place. Now let's see about the aeration system. So aeration system normally it ensures proper oxygen supply is ensured for every microbes that is placed in the fermenter. So here normally the fermenter is also designed with the fermenter having a sparger which is mechanically less input can be given, and high mechanical input can also be given based on the type of product which you synthesis. So here the types of sparger includes porous sparger, orifice sparger, and the nozzle sparger. So this let's see how the sparger or the aeration system is normally specified. So it's based on the size of bubbles that is produced by the sparger. So when you need to mention about the sparger system, you need to also mention about the size of bubbles that evolve from a particular fermenter. So let's see some of the types of the sparger. So first is the porous sparger. So here the porous sparger size of the bubble is very huge, starting from 10 to 100 times the pore size of a particular sparger. So its arrangement is normally in that way, and similarly there is a problem that if microbial organisms grows more, then there is a clogging of this particular pores is also a problem is there. We need to shoot out. In order to shoot out, we can go for selecting for other spargers. So this is an orifice sparger. It is otherwise called as ring sparger. The arrangement is made in such a way that the ring shaped metal is arranged around the fermenter bottom, and it is having a stripped holes that provides the oxygen for the supply for the microorganisms to go. Next is the commonly used sparger is nozzle sparger. This is a advanced sparger system that is placed in the bottom of the particular fermenter along with the handle over at the top. So it will facilitate the oxygenation and aeration very well. So it's commonly used in the industries. And here is the next is the fermenter, which is a combined type of fermenter that is facilitated with the combined sparger aeration. Here agitator as well as the sparger is attached in a single unit. This can also be used. This is the reason why. And here next is the finally we need to consider the aseptic condition maintenance that need to be taken care while designing the fermenter. So while not only the elements that you take care in designing the fermenter is important, also the maintenance of the aseptic conditions. For that we need to ensure some certain parameters. One is the sterilization of the fermenter as a whole itself. So it can be accomplished by passing a hot water inside it or steam inside it, and then followed by air supply which we provide should also be free from pathogen. So the air that we provide for a particular fermenter should also be in a sterile condition. And during agitation and aeration, so if we are fixing any agitator inside, then that should also be sterilized before the fermenter is starting its operation. Followed by when we add or when we take up any samples, that should be performed in such a way that it doesn't affect the aseptic conditions of the fermenter liquid. And during sampling, as I said earlier, as well as the foam, which also play a vital role. If the foam is not controlled, then there is a chance for getting contamination during the fermentation process. And monitoring and control of the parameters is an essential task that we need to take care during the continuous process of fermentation, which takes care of every element and helps in providing your fermenter part in a specific way that you achieve your product in a desired manner. Thank you.